Hi friends, today we are going to look at numpy which contains n-dimensional array objects, tools for integrating with C, C++, and linear algebra, Fourier transform and random number capabilities. So let's see how we work with numpy. So here we will see now what is numpy and how to slice, dice and work with numpy. So first of all we are going to import a module for numpy as np, and then we have defined three arrays. Okay, each of them being different, having different dimension. There's a one-dimensional array, there's a two-dimensional array and a three-dimensional array. So you could have n number of dimensions, but for example I have given a 1, 2 and 3-dimensional arrays. So just have a look at the square brackets that each dimension has. So a 3-dimensional array will start with 3 square brackets and end with 3 square brackets, so on and so forth. And we are going to see and now we will go and see what are the properties of these arrays. So each of these n-dimensional array will have a property called ndim, okay, which is nothing but the number of dimensions. So 1 for 1 dimension, 2 for 2 dimensions and 3 for 3 dimensions. Then we will have something called as shapes. Okay, so each of these array will have also a shape. What is a shape? Shape is nothing but what are the number of rows and number of columns. So one dimensional array will have a single row and 3 columns. A two-dimensional array might be, in this case, would be 2 rows and 3 columns, and 3-dimensional array will be kind of different. It will have 2 into 2 into 3. Okay, so there are basically 3 dimensions. So 2 rows in one dimension, 2 rows in the other dimension and 3 columns. So that is how the shape is given. And what is a size? So size is nothing but the number of elements in the array, which is nothing but the multiplicative factor or the product of all the dimensions. So it will be like, if it's a 2 cross 3 array, it will be 6. 2 into 3, 6. 6 will be the size of the array. So that's the property size. Next, the property is called d-type. D-type is nothing but the kind of data that is there in the array. It could be integer, it could be floating point. So that's how it is defined. So if even one of the elements or one of the rows in an array is floating, the rest is integer, the array is when you print the array, it will convert, or when you use the array, it will convert it into floating point and show the array. So that's how it is defined. Now the next, what we call as item size. Okay, item size is nothing but the byte, number of bytes, okay, in the array. So whether it's 8-bit, 4-bit, 32-bit, so this is what it's going to show in the item size. And then there is a property called data, which is nothing but the buffer which contains the data. So you will get a memory location when you type dot data, it is going to show the memory location. But anyways, we will not use this data part anywhere, okay, because arrays anyways are accessed using the indexes. So we don't commonly use the data property. And finally, it's the array itself where you're going to print the array, which will be basically, there will not be any properties. You just give the name of the array, my 1-dimensional array, my 2-dimensional array, and so on and so forth. So it is going to print you the array. So this is what are all the things that are involved or properties of an array that you are going to define. So the numpy array is similar to the basic array that is already there in the Python, which is np.array is similar to array.array. But the difference is the number of operations that you can perform on these arrays are huge. So now let's see how it shows. So you have the output of all these. Okay, so now if you see the output, you will get the different properties being printed there. Okay, what is the endim, what is the shape, what is the size, what is the data type, so on and so forth. Now there is, let's assume you want to create random arrays or arrays by default. So you can use something called arange. So arange is a function in the numpy package which will create arrays automatically. So when you give my new array is equal to np dot arange of 9, it will create a array with 9 elements. Okay, or if you give 6, it will create with 6 elements. In this case it is 6. Now let's put 9 and see how it creates an element of 9. Okay, so by default when you use array arange, it will just go to create a simple list. Okay, it will not be an n dimensional array, or it will be a single dimensional array in a way of speaking. So it has created a array now. So let's see how do we shape the array. So if you want a 3 cross 3 array or a 4 cross 3 array or a 2 cross 2 array, so you can give a reshape function. There's a reshape function where you can reshape the array. So the one dimensional array will become two dimensional array. So I'll give my new array dot reshape 3 cross 3. Since we have 3 cross 3 is 9, so there will be total 9 elements. So the 9 elements will be split across into 3 columns and 3 rows. So that's how it comes. Now let's give something which is 4 cross 3 or something else, and let's see how numpy behaves. Okay, whether it fills it with zeros or it gives an error. So I am going to give a 4 comma 3 and then print and see what it says. So yes, so numpy is giving an error here, which basically it is saying that 4 cross 3 is 12, not 9. So it's intelligent enough in that way of speaking, saying that which it calculates what you have given and what is already present in the array and throws up an error. Now there is another way of creating these automatic arrays. Okay, so we can give the starting element, the ending element, and the number of steps, and even the data type in that. Okay, let's try doing it. Okay, see here. So it shows what are the possibilities. So you can give a start, you can give an end, number of steps, data type, etc., etc. So these are the arguments you can pass to the arange function. So here I have given to start with 0, end with 10, with steps of 2. So basically it will take 2 steps, or rather it will have 5 elements from 0 onwards. So 0, 2, 4, 6, 8. So the end step it will skip. That you need to remember. Just like a list, the end value will be skipped. So it will be 0 to 8. Now let's change it to int. So you can see the difference. When you gave float, it was giving dot 0. Now it will remove the float. Now I will reshape it as well. So actually, practically speaking, numpy is highly used in working with matrices. Okay, so that's one of the application of numpy. Okay, it's more used by the scientific community. Okay, for to perform calculations. And okay, let's make it 15 because it might still give an error. We need to put 2 into 2 into 2, which is 8. Yeah, so now it comes. So it has created an array with 8 elements, and we are going to put it in a 2 cross 2 cross 2 3-dimensional array. Now we can also create ones and zeros array, which means you can initialize an array with all ones or all zeros. There's a built-in function np.zeros with the dimension, with the size, or sorry, with the shape will give you the zeros array, and np.ones with a similar shape will give you the ones array. So these can be used to initialize your matrix or array using numpy. So the first one will give np.0 will give you a 3 cross 4 array. The second one, let's put a 3-dimensional array here. So yeah, so it will give a 3-dimensional array all with filled with ones. So you have a all 0 array and all 1 array. So the zeros array has 3 rows and 4 columns, and the ones array have 2 arrays, or rather 2-dimensional array of 3 rows and 4 columns. So as I told, these can be used to initialize your matrix or array in numpy. Now we will see the use of dots. Okay, so basically when you have a big array with lot of elements, so numpy while printing it will print it as dots. It will print some starting elements, then 3 dots, and then the ending elements. So let's see how big an array makes it print the dots. Let's give 1000 first and try it out. Okay, it still prints with 1000. Let's give one more 0 and see. Yeah, here you go. So it says 0 1 2 dot 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 997 998 999, so on and so forth. So this is how it works. Okay, let's give it some dimension. Again, just remember the dimension should be, the product of the dimension should be equal to the size of the array. So it should be 10 10 10 10 10, 4 tens, 4-dimensional, or 100 into 100, so or 10 into 100 into 10, so for a 3-dimensional array, so on and so forth, or 1000 into 10 for that matter. So yeah, here you see again it prints with dots. Now let's make a 4-dimensional array and see how it comes. Maybe 10 cross 10 cross 10 cross 10. We will see now we can use dots as well to get back the information. Okay, but before that let's make it smaller so that it's easier to view. Okay, 3235 or something like that. Yeah, 3 2s are 6, 6 5s are 30. Now let's see how to use the dots and print. So this is a three-dimensional array. So I am going to give 1 comma dot 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 comma or dot dot dot, which means it's going to print the second row and the rest of the data in the first example. In the second one, it will print all the data second column, third column. So it has printed the second row or the second dimension, which is 10, 11, 12, 13, 14, 15, 16, 17, whatever. Okay. In the second example, you will see it will only print the third column. Now let's see, can we do it with the middle dimension. So it's kind of 3 comma 2 comma 5. So let's try to give dot 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 comma something comma dot dot dot. Will it print? Let's see. So we are going to give comma dot dot dot. So ideally this would give an error because this is not how it works. There's another option. Instead of dot dot dot, you could also try with colon wherever we have given dot dot dot. So here you see the full array, the second array out of the three, which is 1 comma dot dot dot, the third column of all the rows and the second row of all arrays. Now we will see how to iterate over each of the elements. So there are two ways. Okay, first we will try the traditional way, where we are going to have for row in the bigger array and then for the second dimension in that, and then the element in that this thing. So it will be 2 rows and 1 column. That's how you can consider it as, or a row, a column and an element. So we have done now for row in my big array, print row. So you get all the rows. Now we are going to call for column in row, print the column. So you will see it's actually first printing one 2-dimensional array, then each of the rows in that array. So same thing. Okay. Now we will put for element in the column, print the element. So now it will print everything. But this is very tedious. So you are writing almost 1, 2, 3, 4, 6 lines of code to do it. So there is a different way that numpy provides. That is called the flat function. So we can say for element in big array dot flat, print element. So which is going to print every element. It is going to make the array flat and then print it. So basically it makes it a single dimensional array and then prints the element. So it happens in 2 lines. So it's simpler. Based on the application, you can use the traditional method or the numpy given flat function. Now we can see how do we do some operations on the matrix or the arrays. So we'll have a 2 cross 2 matrix. Keep it simple. We'll initialize an array, np.array, of 4, 5, 6, 7. So it's a 2-dimensional array. So now we are going to the second array, we are going to create automatically. So let's call it my 2 cross 2 auto matrix or automat will be np.arange, okay, with 4 elements, dot reshape 2 cross 2. Okay, let's add it. Plus my 2 cross 2 automat. And then we'll see the subtraction also. My 2 cross 2 sub result. Yeah, the plus becomes minus. Let's add multiplication as well and see how it adds, subtracts and multiplicates. So here you will see that the multiplication will not be a matrix multiplication but will be a element multiplication. That is basically the first row, the first column will be multiplied of the first matrix will be multiplied by the first row and first column of the second matrix. Here are the results. So it has added each of those. 4 plus 0 4, 5 plus 1 6, 6 plus 2 8 and 7 plus 3 10. So similarly subtraction also, and incidentally it's all 4 4 4 4. And then multiplication, if you see, it's a direct multiplication. It's 4 cross 0 is 0, 5 cross 1 is 5, 2 into 6 is 12 and 7 into 3 is 21. So that's how it has done. So it's element wise multiplication rather than an actual matrix wise multiplication. We will see how to do matrix wise multiplication also later. So let me reiterate. Operation is performed element wise. Okay, it's not a matrix multiplication. Now we will see, now we will see the use of random. Random is a function which is given to generate random numbers. So here we are going to generate a random matrix 2 cross 3 matrix. Okay, and then print it. So it's going to generate a random array. So this random, every time you run you will get a different element. See here. So the elements are different for every run. So it's just picked up randomly. So along with this you have the sum, min, max. Okay, this is nothing to do with random, but on any array or any matrix you can apply these functions. Okay, the minimum, the maximum, the sum and all those things. Okay, you can also use a transpose. It's capital T, which will basically transpose the matrix. So if you remember last time when we installed pandas, it also installed numpy as a requirement or a dependency. That is because when we use pandas, internally it uses numpy. So when we read the Excel sheet and tried to transpose it, it internally uses numpy to do the same. And it also showed us the minimum, the maximum, okay, the standard deviation, average, these kind of things. So basically internally it uses numpy to perform some of these operations. Okay, now I forgot to show you the matrix multiplication. Let's go back and see how do we do the matrix multiplication. So there is a function called dot. So there are two ways to do it. Okay, either you can say my 2 cross 2 matrix dot dot my 2 cross 2 automat, or we can say np dot dot my 2 cross 2 matrix comma my 2 cross 2 automat. So both will do the same operation. So it's two different ways of doing it. Let's print and see how the results come. Yeah, there you go, the output. And for some who perhaps might have forgotten how matrix multiplication is done, let's quickly write it down and verify. Let me open Notepad and see how it's being done and then verify, so that if you remember, well and good, else it's kind of a revision. So these are your matrix 4, 5, 6, 7, 0, 1, 2, 3. So when you multiply, it will be the first element, which is row 1 column 1 into row 1 column 1 of the second matrix, then row 2 column 1 into row 1 column 2 into row 2 column 1 of the second matrix, and similarly the rest of the thing, and then you add it up. Four into 1 into 5, 5 into 3, 6 into 2, 6 into 0, 7 into 2, 6 into 1, 7 into 3. So that's how it's done. You do it, you will get it. So 5 into 5, okay. So that is matrix multiplication using numpy for you. Now we can also actually split an array, or stack two arrays horizontally, vertically, split it horizontally, vertically. There are functions called h stack, v stack, h split, v split, so on and so forth. So that's going to split the array. So let's see the stack functions. H stack array 1 comma array 2. So it's going to stack the two arrays horizontally. So 2 cross 2, 2 cross 2 will be stacked horizontally. So there you go. So one is stacked horizontally and one is stacked vertically. So it's basically like concatenation of two arrays. We can as well split them. We have H split and V split, and we can give how do you want to split it. So this is a small matrix, so I'm going to split it into two parts. A bigger matrix, you could try splitting it into three parts as well, and it will split into different arrays. So each split part will be a array now. I guess the split and the stack functions were written by two different guys, so one requires an extra bracket and one doesn't require it. Anyways, we should be always thankful to the open source community who give us so many libraries that we can use and make our life easier. So here you see multiple arrays. So there is one array, two array, and this is another array. So it's being split differently. One is horizontally, one is vertically. Now we will see how to copy an array. So there are three ways to do this. Okay, one is a way where you create two variables pointing to the same array. So it's basically two names for the same array. So you modify any of the arrays, both of them get modified. Okay, that's one way where you basically say array 1 is equal to array 2. So what it does is it actually gives two names to the same array. Now let's change the shape of the array. So first initially I have created an array which is one dimension. Now I'll make it two-dimensional array. We'll change the shape of the duplicate array. Now we will print the original array and see what is the shape. So it has changed the original shape also from one dimensional array to a two-dimensional array. So basically this is one way. Okay, here changing the shape of the duplicate changes the shape of the original array. So next we will see the view. So what we call as a view. Okay, where you create another array object, but the data it refers to is same as that of the original array. So we will call orig.view. So it's a function. When we say orig.view, yeah. So you see the shape of both is different here. Okay. Yeah, now it changed. Okay. So the orig shape is still 2 comma 3, whereas the duplicate shape is 3 comma 2, as against the first one in which changing one changed the other one as well. Okay. So now there is something called as a deep copy, which actually copies one array into a different. So there will be two different objects with two different data contents. So the second array does not refer to the first array anymore. So we have a function dot copy. So in the second and the third, it doesn't change the shape of the original array. In the second, so how do we check if the data is shared or not? So there is a function called base. So I'll say do dot base is orange. If it is true, then the data is shared. If it is false, it is not shared. So here you see. So for the second one, that it is true, which means it shares the same data. For the third one, it's false, which means it's a different new set of data which is there. So how do we reshape? You can actually automatically reshape your array as well. Okay, so you are going to ask numpy to reshape it itself. So in this case, I've created 40 elements array. I'm going to give a -1, 5. So it is going to auto determine what -1 will be. So let's see the shape. It should be 2 into 2 into 4 into 5. So it has taken the 4 automatically. So -1 will auto determine the shape. Okay, let's see how intelligent it is. What if what will happen if I give 2 minus 1? Will it do or will it not do? It's going to fail, but let's give it a try. Okay, yeah, so it failed here. So it can only determine one dimension, it cannot determine 2 dimensions. Now let's go back and see how do we use numpy with your matplotlib. So let's plot a graph, a histogram graph, okay, which using matplotlib. There are two ways. So one where the histogram is done by matplotlib. Second, numpy in it has its own histogram function. So let's use numpy's histogram function and then plot it using matplotlib. So both we are going to try out and see what is the difference, how it comes. Now it's for you guys to find out what I am doing with this vector statement. Okay, just try googling around or try to find out what the np.random.normal does. It will be a nice assignment for you. Okay. So I'm going to use plt.hist. So that's what we used last time also. So this is like same as last time. Okay, so the input here is the automatic range that we have created. So here you see a range. Okay, so it peaks at 3 and then goes down. So it's basically a normal distribution, random.normal. Now we will do the same using histogram given in numpy, histogram function of numpy. So there is a histogram function. We'll define n comma bins. So we need to know the number of bins is equal to np dot histogram, the vector which we have generated, and the bins being maybe 100, and normed. We have a normed in both of those. The difference is in one of them we give normed is equal to 1. In when you do it using numpy, you are going to give true or false. So normed is equal to true. We are going to use the same thing, 0.3. So this is your histogram. So there is a difference. If you look at it, there is a difference. So this is about numpy, and that's where we end this session. So we will meet again in my next session. Till then, goodbye.